Let's take a look at another example of how we're going to graph a quadratic inequality. Remember, the first thing we're supposed to do is graph the quadratic equation, or graph what the quadratic equation looks like. So I'm going to graph y equals 2x squared plus a negative 3x. I'm going to write plus 0 so I can see that this is in standard form. You don't need to do that, but just be aware if you were to need that c, it would be 0. It's really more important that if you didn't have a b term that you wrote 0x in here. So remember, looking at a sketch of a quadrant plane there, quadrant grid, we know that this leading coefficient is positive. That means my parabola is going to be opening up. I don't know where on the quadrant it is going to be opening up. I'm sorry, coordinate plane is going to be opening up, but somewhere on there. I need to know what that middle point is. The way we find out what the middle point is to use negative b over 2a. So just take your information up here. Negative, my b is a negative 3, over 2 times my a, which is 2. Negative 3 is a positive 3. 2 times 2 is 4. 3/4, if you want to, you can write that as 0.75. Okay, if that's a little easier. So I know that is going to come in the middle of my graph. It's going to be the vertex. So we pick a couple values on either side, maybe 2 and 3, maybe 0 and negative 1. Again, I just selected those. These are my inputs, my x's, and what I get out are my y's. Okay, so plug this into calculators. Right here into this formula, so now I'm going to plug in 2, and then in parentheses I'm going to put a negative 1 squared plus negative 3, or you can use minus, times the negative 1. I don't really need to use plus 0. But when I do that, I get 5. Okay, and then I put 0 in here, and I get 0. And then I put 0.75 in there, and I get a negative 1.125. Then I put 2 in and get 2, and I put 3 and get 9. Okay, so we use this to find the x value of our vertex. And then we find input-output values, and we're going to graph these relations on a coordinate plane. So I'm going to graph it on here. I'm going to graph negative 1, 5. I'm going to graph 0, 0. I'm going to graph 0.75, negative 1.25, so kind of in there. I'm going to graph 2, 2, and 3, 9. So it's 5, 6, 7, 8, 9. Okay, so you can kind of see this parabolic shape here. As always, it's very difficult for me to graph these. Someday I will learn to do this better, hopefully. Until then, please be patient with me. Well, as far as I am concerned, that's pretty good for me. So we're going to go with it. The only thing is, look right here. If it's just less than or just greater than, it does need to be a dashed line. A dashed parabola, I should say. So let's make this dashed. I can cheat and just kind of erase this out. And if you use pencil, feel free to do that. Okay, because it's hard to draw a dashed parabola. Okay, so you just want to make sure that we can see that it's dashed. Okay, so now the last thing we're going to do is we have to test a point. Normally we test 0, 0, but you see how our parabola goes through that point. So you can't test 0, 0. Pick any other point you want. I'm going to test the point 1, 1. Okay, you could test 0, 2. You could test, I don't know, 7, 0. Okay, but test any point you want. But I'm going to take our original inequality of y is less than 2x squared minus 3 times x, and I'm going to test the point 1, 1. X value, y value. And I'm going to say, is 1 less than or equal to 2 times 1 squared minus 3 times 1? Is 1 less than 1 squared is 1, 2 times 1 is 2, minus 3 times 1 excuse me, is 3. Is 1 less than negative 1? No. 1 is greater than a negative 1. So what that means is this is not a solution. 1, 1 is not a solution. So you have to shade outside the parabola. This does not make our original inequality true, so you just shade outside the parabola. Graphing quadratic inequalities do take a little bit of work, but the more you do it, the easier it gets. Because keep in mind, you graph the quadratic using your negative b over 2a to find the x-coordinate of the vertex, make an input-output table, graph it. Then, or before you can do this, make sure you double check to see if it's solid or dashed, and then test a point. Use 0, 0 whenever possible, but if your parabola goes through 0, 0, test any other point you want. If it makes it true, shade wherever your point is. If it's inside and it makes it true, shade the inside. If you picked a point outside and it makes it true, shade the outside. But like in this case, 1, 1 was not a true statement, so we're going to shade the opposite. We're going to shade outside the parabola.